This conference will now be recorded.
When I execute a Spark program, let's say I have did Spark submit. We have not yet done the Spark submit. I'll tell you. Let's assume that I have submitted my Spark job. Behind the scene, what is actually happening in Spark flow? We can call it as a Spark flow. Can anyone explain me? Suma? Can you explain me more?
Yeah, so the driver program initiates the Spark context, and it will also create the DAG, so which will be converted into physical execution plan.
Okay.
So the physical execution plan will have the stages, and the respective stages will get executed on the worker nodes or on the executors.
So who will launch the worker nodes?
Cluster manager.
Cluster manager, okay. So how the stages will be created?
Based on the DAG and the number of partitions.
Is the stages will be created based on the number of partitions? How the stages will be created? Anyone?
Based on transformations.
Based on
narrow and wider transformations.
Narrow and wider transformation.
Okay. Okay. Let me start my mission. Actually, I started by 8 only, but it stuck. Then I restarted. So that's the reason everything went off. Okay, good. Okay. Do you guys have any questions to me? If you guys don't have any question, the reason you guys might have preparing.
What is the difference between the worker node and the executor?
Can anyone try answer that question? What is the difference between worker node and executor?
Worker node is like a data node we had in our HDFS architecture. So these are the multiple machines connected in the cluster. Executor is a program that is run through driver on on worker node. It is managed and arranged by cluster node when driver requests for the resources to run the program, to execute the DAG actually.
Executors will run the tasks. It is a JVM process.
It is a JVM process. In one worker node, based on your number of resources, like number of cores, RAM, disk, and all, we can create a multiple executors. Multiple executor. One executor is nothing but a child or JVM process, which will run multiple tasks parallelly. One worker node can have multiple executors based on the capacity of the node. I have explained this earlier. Am I not explain this? I didn't explain this.
Yes, you did, but I have little confusion.
Okay, good. Okay, any other question? Okay, let's jump into the next type of transformations. So let me I have started sharing my screen. So please let me know if my screen is visible or not.
Yes, visible.
Okay. Yesterday I have asked you guys to do a fold by left to fold by right or something. So how many of you did that? fold left, fold right, not fold by. So fold by key was different. Did anyone get a chance to do that? Yes, no.
No, Ravi, I didn't get a chance.
Okay, so I'm going to show you, but anyway, I'm not going to explain that fold left and fold right. So try this weekend by going through the pending videos. If anyone is not didn't gone through the last few sessions, please go through it. Try your own, but the concept I have already explained. Try your own with a different example. Then we'll discuss if anyone has a doubt about it. Everyone, I want to say everyone to try some of transformation by your own. Okay. Okay, let me. Okay, it is a filter min max. Basic transformation part 2, I'll say. Okay. Basic part 2. Basic transformations part 2. So for the next step, we will create Spark. Can anyone help me to complete this? No?
Happening. Then get or create. Then you need to create a context. Spark dot spark context.
Okay. Spark context. Okay, let me show you. I think we have already seen for each. I have already shown you for each. What the for each will do? What for each will do? It will traverse through collection. It will traverse through a collection, and whatever the functionality you provide here, that functionality will be applied. Okay. By the time we start Spark shell also. Okay, let me show you as part of this. I'll be showing you. And one more thing, everyone please download that now. Spark transformations and actions. There is a PDF document given by Databricks. Okay. Yeah, this one, Visual API PDF. I'll share the link to everyone.
Ravi, what is this Databricks? Is it like Spark Shell or
Distribution.
IntelliJ?
No, this is a one distribution like Hortonworks, Cloudera. Okay. The Databricks, they are good or topmost contributor for Spark. I have pinged the chat window, the PDF path. Okay. I will take you guys through this PDF for a few concepts which we already covered. Okay. You can see the history of this, founded in 2013 by creator of the Apache Spark, and originally it is called UC Berkeley. Okay, I didn't talk about I think the history about the Spark. So the Spark actually started by the 4 or 7 students actually. So they started this project as a testing framework. How they started, we have a MapReduce, right? So they will when you launch a MapReduce job, they want to understand how the framework is utilizing the resources, whether they're utilizing the 100% resources or it's not utilizing. So to make the framework to utilize 100% resources, whatever the resources we are allocating. So they started as a small college project. Okay, later slowly it will turn into Spark. Okay, and it become a number one in the Apache stack. Okay, so it is a widely using component from Apache stack. How many of you know Apache, the foundation, the software foundation? So where you can get the free softwares, everything you will get the free software. Okay. Okay. So it's RDD. So if you see wherever you see like this, you consider as a partitions. Okay. This is okay. You have a transformations and actions. Transformations are transforming, okay, from one state to another state. You're transforming your data from one state to another state. That's the reason we'll call it as a transformations. Actions are nothing but it returns your value, right? That's the reason we'll call as action. Just represent with the symbol, this one. Okay, you can see here. I request you guys to download this PDF. Keep with you. Okay. These are some of the transformations. The map partitions, map with partitions, we will be talking about I think next session. This is most important. Map partitions with index. Okay, these are some basic easy and frequently using transformations and actions. Look at here: reduce, collect, aggregate, fold, first, take, for each, top, and some other. For each also an action. Min, max, sum, mean, which we have seen in the last session, they are actions. Count. Okay, I didn't talk about the count. Let's see about the count. What is the count? Can anyone tell me? What's the
It counts
count?
the number of elements in the array.
Yes. It counts how many records are there in the RDD. Okay. Okay, let me show you one simple basic example from the for each. I think I do have animals like a cat. No problem. If you don't have, I'll create one. Let's take val animals equal to list of animals. Okay, dog. cat figure ion what else? I'm just taking some random strings I need, actually nothing else. Okay, okay, some animals I have taken. I just want to loop through. I want to create an RDD and loop through, I mean print those things, nothing else. So that's what for each will do. For each, what it does, like it takes an, I mean, collection, okay, goes through the collection, travels through the collection, and whatever the functionality you apply on it, it will apply that functionality. For example, this is animals, right? Let's say create var val animal RDD equal to sc dot parallelize c dot parallelize animal RDD dot for each println for each println. Okay, normally people will think like if I write println of RDD, it will print. Let's look at what it will print. Okay, it will just print what type of RDD it is. Okay, it has been created using the parallelize method. It will not actually print the content of it. To print the content of it, you have to apply the action, right? For that, we can say like this. We can use the collect. Collect is an action. You can use the collect. Collect is an action. So by default, as you guys know, that it will create 8 partitions. In my case, in my case, it's 8 partitions, and you see that some of the partitions are empty. Okay, so let me take an example. This one. So what else? Iterate through. We will be using this, but now we'll never recognize it as a separate action. Okay, we'll be frequently using the for each. Okay, you can see RTD dot for each println, and there is another version of it, RTD dot for each. You can take element and you can apply. You can do whatever the whatever you want to perform with this println if you want to take something here, animal, then print animal. If you want, you can apply like this also. You can do like this. Okay. So for each is the one, when you have a collection, it will traverse through each and every element and it will print. Okay. Okay. So I have shown you a gloom. What the gloom did? What the gloom did? It's showing you printing the elements based on the partition wise. Correct? Based on the partition wise. Let's see. I want to loop through partition wise and print. Okay. So there is something called for each partition. There is something called for each partition. Let's see that how it will work. I have enable RTD. Okay. For each, I don't think it's available now. But anyway, let's see. Yeah, for each partition, just to print it. Non-empty iterator, non-empty iterator, non-empty iterator. It's showing that it is not, it is iterating. Okay. Non-empty means there is a value in it. That's the meaning of it, but it's not printing the value. Okay. So for that, what I do, I'll do like this: element println, then just print really. I'm just printing really. Oh, it's also saying that non-iterator, we cannot print this one. Okay, 1 second. Let me do one thing. I just want to see the functionality of this. You guys can look at here. It's iterator, return unit, applies function f to each partition. It applies the function f. Okay. Let me write a simple function. But anyway, this is what the function I have written is okay, right? I'm taking the element, I'm printing the element. Why it is not considering that as a function? I'm taking element, I'm printing the element. It's my function. Let me do element dot concat it cannot be implemented. But why it is not printing? iterator. It's printing wild only.
Ravi, can we look at the definition of this?
Yeah, just one second. So first partition, it's empty. It's printed wild. Non-empty is printed wild. But why element is not getting printed? Okay, we can see the definition of this here. Applies a function. What are the function you write here? Applies a function. Each function. The function also iterator function. Okay. Let me take like this. RTD dot element dot okay element dot map this one one it should be iterated one. But it returns another RTD. Let's look at this. Let me do one thing. I think I want so many numbers like till 35 or something because I don't want to have empty partitions. Yesterday only we created, right? Number RTD. RD dot gloom dot collect. Okay, it's showing array by array. Let me do RD dot for each partition. Take element. Let me do some every element, every partition-wise sum. Let me do partition-wise sum. Println and this element dot reduce fold. I can take fold 0 Let me see. What is the what? There is no. We'll see first one. 10. It's a partition 1. Oh, it is a partition 1, which is 10. But if I print some partition number, it will help me, right? Here the element is coming. Element means complete partition. Okay, we need to understand here element is nothing but complete partition. Complete partition is nothing but array. Okay, I want to get the partition ID. If it is a map partitions with a map partitions, we can easily print that ID from which ID it is coming. Okay, let's assume this is the first partition. Let's assume that it's a 10 is the first partition. Like 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. The next one is 11, 18, 18 plus 8, 20, 26.
26.
26, second partition is there. And here 19, 30, 30, 42, 55. I think we have a 55. Yeah, it looks all partitions are there. But if we print partition wise, that will help me more. Okay. Since we are talking
Ravi,
about
we
this,
can do the sorting. Ravi, we can do sorting since the numbers are in increasing order. So the sum will also be increasing order.
dot, it's not allowing.
We can create another RDD and then print out.
No, it will not. It is an action, right? It is not
Oh yeah, for each. Yeah.
transfer. It's not transformation. Okay,
Mm,
it
print.
is.
Yeah.
It returns a value. Okay, let me show you similar kind of functionality. Okay, let me show you a similar kind of functionality where there is something called map partitions. Okay, let me anyway. This one, let me make note. This is the data. Okay, dot for each partition element print element dot. You can use the fold or you can use reduce, whatever you want. Okay, you can use anything, whatever you want. If you want, you can use this. Okay, you can use whatever both are same. Fold left and also does a similar kind of operation, but it will take the initial value as 0. Reduce will not take any initial value. Okay, and reduce will not take any initial value. It will directly take the elements and it will test. Okay, so that's okay. You can do fold left also. Example, fold. Let's see. Okay, since we are talking about partition-wise operation, there is something called map partitions. Okay, so we need to understand, this is also another important interview question, guys. What is the difference between the map and map partitions? Map and map partitions. Map partitions is similar to map, but it applies the operation partition-wise. It actually partition-wise it runs. Okay, you may say that, sir, even map also it applies on the partition 1 and partition 2, partition 3 separately only, no? So how it is different? Okay, it is going to apply map function whole partition value at a time. It is not element by element. You guys getting what I'm trying to say? Your map, what it does, it take element by element and applies the functionality. That's what map we understand. Yes or no? Yes or no, guys? The map transformation, what it does?
Yes,
Read
sir.
one element, it applies the functionality and element by element. But map partitions, it takes partition by partition. It means all the elements in a partition will be taken as a single transformation and applies that. Let me show you an example for it. Okay, it is not element by element operation. It is a across the what I can say, across the whole partition by operation. Let's take a simple example. Okay, so for this I'll write my own function. I think I have written last time some my own function. The function is summing. Very simple, guys. Sum function. Okay, we're going to do a sum. What you will do here, you will take some num, you'll take some numbers, which is integer type. This number, you will do the sum and return the int or long double or whatever the number you want. Okay, this is your program you're going to write. What this program will do, it will just take numbers, it does the sum of it. Okay, for that what we will do, var sum equal to 0. Normally that's how we'll do the sum, right? Sum equal to sum plus the number whatever you pass. At the end, you will return sum. In Scala, you really no need to write a return statement. The last expression itself is a return statement. I hope everyone knows it. Or you can explicitly write return. No harm in it. Okay. Now, this is my data and this is my number RDD. Look at here. I'm going to apply some transformation on this number RDD. So let me put it map trans equal to dot map. Actually, this map, all these higher order functions, what they do, they will take another function as an argument. Okay. So what is the issue here? Type mismatch, expected int, but nothing for you. Remove this bracket. We should not pass the bracket because it should take automatically. Okay. Look at here. What will happen, when you apply like this in the number RDD? Okay, let me copy paste that also. When you do the number RDD, the gloom will return like this, right? So for our reference for later, when you do like this, when you do the gloom, you'll get like this. Partition by partition. The above ones are partitions, guys. Okay, nothing else. Okay, you have a values like this, partition by partition. Okay, partition by partition. So now when I apply this function, what it does, let's assume that my operation is performing on the first partition. It takes the first element, 0, sum is 0, sum equal to sum. What I have passed number here? 1. So your sum will be 0 plus 1, which is 1. Next, your number will be 2, number will be 3, number will be 4, and so on, right? Let's do this one. It will do the summation based on the numbers you pass. Okay, I have defined my function here directly. I'm writing this. It's a num RDD only or just RDD? It is just RDD. Okay, so I should not say num RDD. I just say RDD. Okay, look at here. Since it is a transformation, it will not return value. Map trans dot collect. What it does? Element by element sum, right? It is summing element by element. So you are summing with a 0. 0 plus 1, 1. Next you pass 2. 0 plus 2, 2. Next you pass 3. 0 plus 3, 3. Next you pass 4. 0 plus 4, 4. Is this correct answer or not? As per your functionality, is this correct answer or not?
Logically, it is not correct
Why?
because we need to sum the elements, and it is like summing with zero only.
No, that is the what function you have written. You see that function I'm talking about. What function I have written? Did I say that I will collect all the elements and do the sum? What it does? You take a number,
Yeah,
sum with 0.
as per the code, it is working properly. But if we say the logic that we wanted to implement, it is not working like that.
No, you have, yeah, that is correct. I understand what your intention behind it. I'm applying the map transformation. Map transformation applies across the partition, element by element. Okay, whole elements in the partition or element by element in the partition. How your map transformation will work? Element by
On
element in
all
the partition.
elements.
Element by
It is,
element by element by element.
yeah, element by element in the partition. Yeah.
Okay, so your map transformation, what it does, it takes the first one. It will take the one value 1. Guys, this is very much equivalent to don't get confused. It's very much equivalent to okay, or I'll put in this way, 0 plus element. Above 1 and below 1 both are same. Above 1 and below 1 both are same. Above 1, I separately written the function. Pretty simple. I have a name for that function. I can make use this function wherever I want. This is anonymous function. Does not have any name. it will be used within the map only. I cannot use this reuse. It doesn't mean that I cannot rewrite. I cannot reuse this anywhere else. Correct? If you are not have any name for any functionality, that will call anonymous function. What is the advantage of the anonymous functions? You cannot reuse them. Disadvantage. What is the advantage? When you want a functionality which will be used only once, you are not going to reuse it, then create an anonymous function. But some func, the line number 36, what I have written, has a name. I can make reused wherever I want within the program. Are you guys getting what I'm trying to say? Yes, no? Yes, no?
Yes, Ravi.
Okay. Let's look at here. This is for, let's say this is for map. Okay, I'll just say map here. Some func for map. Okay. Because I'm going to write one more function to make it clear. I'm writing one more function, def some func. It is not for a map. It is for map partition. It is for map partition. What map partition? See, normally whenever you try to remember one thing, guys. Whenever you want to write a functionality for the map, keep in that mind, map works based on the element by element. So that is the reason you have to take element by element only. So you have to write your functionality accordingly. But when you're writing a function for the map partitions, you should remember that, or you should keep in mind that it is not going to take one element. It is going to take iterable of elements, collection of elements, iterable of elements, collection of elements. Num, it is not a single thing. It is a iterable of elements. So I'm taking iterator. My iterator is integer type, and at the end it returns. At the end it returns iterable of, because partition by partition applies. No, it's not going to apply by element by element. It's going to be applied partition by partition. Iterator of int. Here also I'll be writing the similar kind of function. Okay, where sum equal to 0. My sum is 0, but here I'm not getting individual value. I'm going to get collection of values, array of values. So if I want to sum the array of values, I have to loop through. Okay, what I do here, I'll loop through the elements with the help of the while. You can use whatever the function, whatever the loop you're comfortable. It doesn't mean that you have to write always same. Okay, nums dot, since it is a iterator, there are some kind of functions are available. Look at the functions. Next, has next, contains, exist. There are different kind of functions are available. Okay, I'm going to do, since I'm going to loop through, right? I should make sure that whether it has a next element, the has next actually tells you whether it has a next element. Let me show you this. Has next is a Boolean operation. It tells you whether it next element is there or not. Tests whether this iterator can provide another element. Returns true if subsequent call to the next will yield an element. So next subsequent call, the next call, next I'm going to use this method called next method. Here I'm going to use next. Okay, let's see. In this loop, inside the loop, sum equal to sum plus number dot next. What this next will do, as per the definition, if you see here, They're all methods from iterator class. Okay, look at here, guys. What the next method will do? Provides the next element of the iterator. It returns you next element. The next element of the iterator, if has next is true, undefined behavior otherwise. Okay, you guys understand what it returns? Has next will return if you have element in the next. Has next will return you to give you, just returns you the element. Next returns the element. Has next tells you whether you have an element or not. Okay, so I don't want to go in detail about this iterator function. Let's look at here. I take the sum, numbers, sum plus next, it gives the element and returns. Then I will just return the sum. I'm just return the sum, nothing else. Why it is not returning? Okay, can anyone tell me why it is not returning? Why it is giving error?
It should return a iterator.
It should return iterator. Very good. It should return iterator. So what I need to do, I should say iterator of sum. Iterator of sum. If you want, you can write a return statement, or if you can just ignore it. Okay. Now look at here. I'm going to use the same function in the map partitions. You'll understand how the map partitions works. And there is one more function, map partitions with index, that also we'll see, but now it's already late, I know that. Map partition transformation here, map partitions here, sum for map partition. Okay, first I need to execute this. Run in the console. It'll define your function. Make use this function. Guys, don't hesitate to ask me if you didn't understand. We don't have a num RDD, it looks. We have only RDD. Now look at the difference. This is the output of it. This is the output of it. This is the output of the map. Okay, I think it's better I'll write here. This is the output of this. This is the output of any of this function. You guys tell me now. What is the difference between these two? It is taken element, both are same functions, guys. Okay, there is no different in this. Here it's a single element, it is a multiple elements. That's the only difference. That's the only difference. Because the map partitions works on the collection of elements. It means the whole partition of elements will be considered. Then it does the operation. But map will take element by element and applies the operation. Map partitions applies the operation on the whole partition. Is this clear? Is this clear? Now look at here, why 10, 26 and all the stuff. It's because if you do the gloom, I think I already have here, right? It's not there here. Okay, let me collect that. If you do the gloom.collect, this is our, oh, I already have here. Partition by partition. Partition 1, what is the sum of this? 10. Partition 2, what is the sum of this? 26. Partition 3, I think we need to calculate this. I think it becomes 55 or something. So partition by partition sum. Partition by sum it is. It is not element by sum. It is a whole partition by sum. That's the difference between map partition, just a map transformation, and map partition transformation. Any questions, guys? Very simple, guys. Just to keep in very simple way, map transformation applies element by element. Map partitions applies on the partition by partition. Whole partition elements will be considered as a single operation and applies that operation. Map partitions will take a collection of elements. Map will take the single element. Is this clear or any questions? Raghu, Suma, Praneeth, Maidar, are you guys able to follow?
Yes, sir.
Any questions, please ask me. Don't hesitate. Even if it's small, please ask me. Venkat? Sony, is that Gauri? The name displaying Sony, is it Gauri? Gauri Shankar?
Yeah, Ravi. Yeah, Ravi. Gauri. Yes, sir.
Okay. Gauri, you have access for this folder?
No, Ravi, actually.
The videos I'm uploading here, are you able to access them?
No, Ravi, I cannot.
Then ping me your email ID once again.
Sure, thank you.
Okay.
Ravi,
Venkat? Yeah.
Purnachand is with me.
Sorry, Venkat, I lost you. I didn't get you.
Purnachand is with me.
Purnachand, you both are. Oh, okay, good. Okay.
We are in the same location, so he is with me.
Yeah, Ravi, I'm here.
Oh, you both are joined together. Okay, good.
Yeah.
So, Purnachandar, any difficulty understanding?
Whatever the topics, like some keywords I'm not getting because it's the first time I'm listening, but the logics you're explaining, I'm able to get those things.
Good. Yeah, I'll sit with you, Purna. Chandra again, okay? Chandu or Chandra. Okay, there is one more transformation, guys. There is one more transformation with the same name. Map partitions with index. Map partitions with index. Okay. So what that map partitions with index does? What map partitions with index does? So map partitions with index, what it does, it actually provides you index number, partition number. This is the first index, partition 0, partition 1, partition 2. Guys, what is the partition? Is nothing but again a collection of array, right? Partition itself is a collection of elements. Your RDD is nothing but a collection of partitions. What is RDD? Collection of data. But how it will collect? Partition by partition it will collect. What every partition, what it contains? Elements. Okay, so partition 0, 1, 2, and so on. So because it's an array, right? So we know that indexes 0, 1, 2, 3, 4, and so on. Okay, is this clear? So I want you guys to try and get the get an example for map partitions with index. Map partitions with index. With the index. Suppose I say I want the partition sum of 10th. 10th partition. I don't have a 10 here. It's 8 partition. So I want a 6th partition element sum. I want 6th partition sum. How we will do? How we will do? So we have to pass 2 elements. One is index, other one is a collection of elements. So based on that, we'll do the sum. Are you guys getting what I'm trying to say?
Yes, sir.
Okay. So yeah, try this one example. If you're able to do it, well and good. If not, I'll do it and I'll show you. Okay. So this weekend, you guys can try, and I want everyone to go through the previous videos, and whichever you guys missed or whichever recap, or I can go through the videos again and come up with your questions. I'm expecting some questions on Monday from you. So for whatever we discussed, it can be difference between Spark and MapReduce. It can be what is a Spark, how the Spark works, what is a partition, what is a RDD, and what are the transformations. I want you guys to come up with the questions, because in interview people will ask, right? You should be able to answer. The sure question is map versus map partition, map versus map partition, map versus flat map. These things people will ask in interview to understand, to know how you understand these transformations. Okay. Any questions, guys? If no questions, we can leave for the day. We'll connect in the next session. No questions? Rishabh, Gauri, Suma, Mahendra. Yeah. If no questions, good. Thank you, guys. Thanks for your time. Have a wonderful day.
Thanks, Ravi.
Yeah. Ganesh, an advanced Ganesh Chaturthi for everyone.
Thanks.
Thanks, sir.
Yeah,
Wish you the
same
same.
to you. Rugi. Bye.
Thank you. Okay, bye.